Welcome back. Here we are going to learn object-oriented paradigm. Now, as we have already discussed the flaws in procedural-oriented paradigm, here we are going to learn that how that flaws is overcome, right? So, the very first thing we will be discussing is the individual meaning of the term object-oriented paradigm. The very first word is object. What an object is. In the language of physics and mathematics, anything that exists in this real world is an object. Anything that exists in this real world is an object. Say it as pen, pencil, eraser, sharpener, all these are objects, right? So anything that exists in this real world is an object. So it is termed as it is a real world entity. Object is termed as a real world entity. Now another term is oriented. The dictionary meaning of oriented is in a particular direction, towards. It is totally directional focused in a particular direction towards. The third term is paradigm. What is paradigm? Paradigm simply says that it is an approach to solve a particular problem. It is a way to do something, right? So what is paradigm? It is an approach or a way to do something. Now, combining all these three terms, object oriented paradigm, what meaning we get is simply read it out in a reverse order. That is, it is an approach towards a real world entity, right? So what is an object oriented paradigm? It is an approach towards a real world entity. Now using this approach, we were able to solve the problem in procedural oriented programming. So let's us discuss the same thing that we discussed in the earlier section. Suppose a person P has given us a problem statement PS. Now being a programmer, what we have to do is we have to write a solution for this problem statement. So what we will be doing is, of course, we will be analyzing, a programmer will be analyzing the problem statement, and at the same moment it will be writing the solution for this problem. That is, he will be developing a program. Now this solution will be designed in such a manner that it will be bound to the person who has given the problem statement. Means only this person will be using the solution that we have designed. So this is how we are going to mount the solution with the person who has asked to solve this problem statement. So this is applied using the concept of object oriented paradigm, right? So basically object oriented paradigm is simply an approach towards a real world entity. Now how this approach is implemented? So this approach is implemented using few of the principles of OOPS. Now we are going to discuss the principles of OOPS. The very first principle is object itself. Now what is an object? We have already discussed it is a real world entity. Now I'm going to add something to it. Of course it is a real world entity that exists in this world, and it exhibits some properties and functionalities by which we are able to identify that what object it is, right? So what is an object? It is a real world entity that exists and exhibits some properties and behavior by which we will be able to analyze that what object it is. For example, suppose if I talk about a bank, right? So bank has multiple customers. Now how those customers are identified in a bank? So those customers are identified in a bank by their own data, that is by their own attributes, that what is their name, what are their unique identification number, what are their permanent account number, and what is the account number in the bank itself. So that customer, each and every customer is being what do you say, identified by the attributes of themselves, right? So every customer of a bank is an object. Every customer of a bank is an object. And what functionalities they are using depends on what type of customer they are. Suppose if they are a borrower, that is they are taking loan from the bank, so they will be treated as they are using the functionality of loan. If simply they are the depositor, they are only depositing the cash into the bank, so they will be treated as a customer who is simply using the facility of the deposit functions of a bank, right? So this is what an object is. Coming on to the next principle, that is class. What is a class? Class is a concept based on set theory of mathematics. As we say in set, that set is a collection of similar type of unique elements. Same concept is of class also. Class is also a collection of similar type of objects. Now, what do you mean by similar type of objects? Here, similar type of object simply means that exhibits similar kind of nature. Just for example, if I talk about pen, pencil, eraser, sharpener, so what are these objects used for? The purpose of these objects is same. So they are categorized under one category, that is stationery. So one name can be given to the group of these objects, that is stationery. So stationery here will be treated as a class, right? So stationery is an example of a class. When we talk about the real world example, as I said, as I take taken the example of a customer of a bank. So there are multiple customers of a bank. So all those customers will be treated as an object, and the bank itself will be considered as a class, right? So when we talk about the bank and a customer relationship, bank will be treated as a class, and here the customers will be treated as an object of that particular class, right? So what is the relation between class and object? See here, I've just told that object is an entity that exhibits some properties and functionalities, that is, it contains some data and it exhibits some functions. And what I said about class, class is a collection of objects. So looking at this figure, you can simply make out that class is a collection of data and function. What is class? Class is a collection of data and function of similar type of objects. So we can simply say class is a collection of data and function, right? So these were the two principles, object, class, and the next principle is encapsulation. Now what is encapsulation? Encapsulation, if you consider a real world example, you can check it out with the medicine, that we use capsules. Okay, we normally often take capsules for some of the illness we have. So what is a capsule? Capsule is basically a collective, what do you say, it is a collection of different ingredients in multiple concentrations, right? So multiple ingredients are taken in different concentrations, and they are just wrapped up in a starch, and a capsule is produced. So the process to make a capsule is known as encapsulation. Here, when we talk about classes and objects, we can simply correlate the term capsule here with the class. The process to develop a class is known as encapsulation, right? So when we say what is the term encapsulation, it is simply a process to develop a class. So by definition, you can say it as the process of wrapping of data and function together in a single unit, because we already know that class is a collection of data and function. So wrapping of data and function together in a single unit, and that single unit will be termed as class. This process is known as encapsulation. And because of encapsulation, we achieve the concept of data hiding and abstraction, right? So when we talk about the real world example, creation of a bank itself is a process of encapsulation. Creation of a bank itself is a creation of a class, because I just said that bank is an example of a class, right? So creation of a bank is an example of encapsulation. And data hiding and abstraction are the principles that are achieved because of encapsulation. Now, what is data hiding? You can simply understand it by the real world example. If I talk about any of the customer of a bank, can any other person access the data of that customer? No. Why? Because data is highly secured and none other than the bank itself, the employees of the bank itself, can access the data. Even the customer can't access his own data directly. Suppose if you want to simply change your address in the bank account, of course, you will not be able to change directly. You will simply write an application and that application will be forwarded to the bank, and the employees of the bank after verification will be updating your address. This is how data is being secured. So this is the concept of data hiding achieved because of encapsulation, right? And now when we talk about abstraction, what is an abstraction? Logical hiding. Exactly. Abstraction means logical hiding. We are simply giving the input, we are getting the output, but how that output is achieved, that internal complexity is totally hidden from the user. And this is what known as abstraction. Again, take an example of a bank. When we just simply go to the ATM machines to withdraw cash, we insert our ATM machine, ATM cards, we just put on our pins, exact amount we want to withdraw, we put on that withdrawal amount. After the verifications, ATM machine just extracts the, we are able to extract the cash from the ATM machines, right? But what internal phenomena takes place inside the ATM machine is totally unaware by the user, is totally hidden from the user. This is what abstraction known as. Abstraction is a process. Actually, it is not a process. It is a logical hiding of the complexities from the user, right? So this is what encapsulation, data hiding, and abstraction is. Now next is inheritance. Inheritance is the concept based on parent and child relationship. The term heredity, you might have heard the term heredity. What it is simply a phenomena where some of the parental properties slips into the child. Just for example, few of the illness like blood pressure, blood sugar, some of the parental properties, like if a father is having a blood sugar or blood pressure, it may get transferred to the child. This is what known as heredity. Okay. Now, when we talk about inheritance, it is simply acquiring of the parents' property, right? It is simply acquiring of the parents' property by a child. This is what known as inheritance. Okay. So in the terms of programming, in the terms of OOPS, suppose there is a class A having some of the functionality F. Now we have to develop a class B, and in class B also we need this functionality F that is already being developed in class A. Now there are two things: either we develop the class functionality in class B itself, or what we can do is we can borrow the function F from the class A. It will be more useful in terms of time, it will be more useful in terms of money. So here the function F is borrowed by class B from A. Now this borrowing of function from one class to another is known as inheritance, right? So the from which the function is being borrowed, that class is known as parent class, and the function in which the class in which the it is borrowed is known as derived class, right? So the first one is known as base class and the later one is known as derived class. So the child is acquiring the properties of a parent. You can also say inheritance is based on the concept of reusability. That something is there already, instead of remaking it, what we can do is we can reuse it that we are already having. Okay, so this is the concept of inheritance. Just for example, nowadays we are using ATM machines of any bank we can use. If I'm having an ATM card of bank ICICI, of course, I'm not going to search for ICICI ATM, even I can make use of SBI bank also. Okay, so this is how inheritance is achieved in real life, right? Now, the next concept is polymorphism. What is polymorphism? Polymorphism comes from the two words poly, whose meaning is many, and morph means form, that is multiple forms. To better understand what is polymorphism, again we can take the example of bank. Suppose that you are in the bank and you are asking the employee of a bank to deposit a money. Of course, it is the responsibility of the bank employee. He will take the cash from you and will deposit in your account. At the same moment, the same next moment, you ask the particular same employee for a information of your particular loan account. Again, that same employee will give you the response, will give you the result of the query that you have just formed, right? Means the same employee at one time he is performing one task and another time he is performing another task, whatever is being asked by you. This is what known as polymorphism. That is, multiple roles are being played by the same person, right? So this is how polymorphism works. So these were the five principles of OOPS, that is object, class, encapsulation, inheritance, and polymorphism. Now the programming language that follows all these five principles of OOPS are termed as object-oriented programming language, right? So for example, C++, C Sharp, all these are the examples of object-oriented programming language. And the language that we are going to learn, that is Python, is also one of the object-oriented programming language. Of course, Python also makes uses of procedural-oriented programming. That is, Python follows both the principles, POP as well as OOPS. So whatever we were able to do in POP, that is procedural oriented programming, those things also can be done in Python. And of course, object oriented paradigm concept is also implemented in Python, right? So this was the whole concept of OOPS. In the next video, we will be covering about Python, the details, the fundamentals of Python. Till then, take care. Goodbye.